Hello and welcome to Boost Chemistry Revision. In this video, we're going to be looking at calculations involving moles. You probably already know a little bit about this from GCSE. If this is your first time here, we offer tutorials and revision tips for A-level chemistry, hosted by qualified and experienced chemistry teachers. We'd love for you to connect with us on social media at Boost Revision, and please visit our website for more information and free downloads. So, what should you already know from GCSE?
You should be able to write the chemical formula from the name of a compound, write balance symbol equations, find relative atomic masses of the elements and relative formula masses of compounds, as well as know what Avogadro's number is. If you're not quite sure on any of the things I just mentioned, then I do suggest you go back to GCSE notes and make sure you're up to speed. The rest of this video is going to review points 6 to 9, which are how to calculate the moles of a substance given its mass, how to calculate the moles of a solute in solution given the volume and concentration, how to calculate the moles of gas in a given volume of gas, and how to calculate unknown masses, moles, volumes or concentrations given enough information about a reaction. Don't forget to download the PDF that includes questions on all of these points to help you check your understanding.
Any answers that we don't go through in the video will be sent to you as a separate answer file later on. So let's get into the moles. The main moles equation you'd have learnt before is this one here, mass over moles times mR. So to calculate the moles of a substance given its mass, we need to do mass divided by the mR of a substance, which is the molecular mass or formula mass of that substance. As well as being able to use it to calculate moles, you also need to be able to use this equation to calculate mass or mR by rearranging it in these three different orientations. Let's start with some examples using this equation triangle to calculate the moles of a substance given a mass. So the first one, how many moles are in 72 grams of magnesium? So we take the mass, which is 72 grams, and we look for the mR, or in this case, atomic mass of magnesium from the periodic table, which is 24.3. 72 divided by 24.3 gives us 2.96 moles to 2 decimal places. If we've got 4 kilograms of copper oxide, then we need to first calculate the molecular mass of copper oxide, which would be 63.5 for copper plus 16 for oxygen. That gives us 79.5. And then we can do 4,000 divided by 79.5, which is 50.3 moles. Have a go at the last one before I show you the answer. Have you got it? So the molecular mass for aluminium hydroxide will be 27 plus 16 plus 1 times 3. So that's a total of 78. So we do 39 divided by 78 equals 0.5 moles. Cool. The next equation triangle you'll have met in GCSE when looking at titrations is this one here, moles equals volume times concentration. One thing to make sure is that you always have your volume in decimeters cubed, whereas it's often given in questions in centimeters cubed. So you may need to do a conversion to make sure you've got the right value to put into the equation triangle. Again, you'll be expected to be able to rearrange this equation in 3 ways to either find the moles, the volume, or the concentration of a substance. Let's just have a look at some examples where we calculate the moles from volume and concentration. It's a good idea to have a go at these first, they're in your PDF booklet, before you watch the rest of the video. Right, so we've got NaOH, which is sodium hydroxide, and we have 25 centimeters cubed of it, and a concentration of 0.1 moles per decimeter cubed. So we need to first convert the centimeters cubed to decimeters cubed by dividing by 1,000. That gives us 0.025. And then we do 0.025 times 0.1, which gives us 0.0025 moles. And at A level, you'd be expected to be able to convert this into standard form, which gives us 2.5 times 10 to the minus 3. I'm hoping you'll have come across standard form before, but if not, drop me a line and I'll be happy to explain it to you. I'll whiz through the next couple of answers. So same conversion first thing, then volume times concentration. The second question gives us an answer of 0.0045 moles, or 4.5 times 10 to the minus 3. Same method again with the third question. So we convert the volume to decimeters cubed. Volume times concentration equals 5.66 times 10 to the minus 3 moles. Finally, we've got the equation triangle that tells us how to calculate the moles of a substance given the volume of gas. So here we've got moles equals volume divided by 24, or volume equals moles times 24. Again here, the volumes are given in decimeters cubed, so you may be expected to convert it into centimeters cubed by either dividing your volume by 1,000 or dividing the whole thing by 24,000 instead of 24. You'll see what I mean in a second. If If you're not sure how to rearrange this triangle, then here are the options on the right. And let's look at an example. So we've got 96 decimeters cubed of carbon dioxide gas. Okay, so we take the volume, which is 96 decimeters cubed, divided by 24, and that gives us 4 moles of CO2 gas. Second example, we've got 2 decimeters cubed, divide that by 24, that gives us 0.0833 recurring moles, which in standard form is 8.3 recurring times 10 to the minus 2 moles of steam. And then the last one's slightly tricky because the volume is given to us in centimetres cubed. So we've got 1200 centimetres cubed of ethene gas, which means we can either do 1200 divided by 24,000, or we can divide the 1200 by 1,000 first, giving us 1.2, and divide that by 24. Both ways will give us 0.05 moles of ethene gas. Now that you've got the basics of using these 3 main types of equations, you'll also be expected to work out an unknown value given enough information in a question. So we've got a couple of examples of those coming up. The first one is to calculate an unknown mass of oxygen from a mass of magnesium. In this first one, we're given the balance symbol equation for a reaction between magnesium and oxygen, making magnesium oxide. And we're asked what mass of oxygen reacts with 192 grams of magnesium. See if you can have a go before you watch my explained answer. So first of all, I always like to start by calculating the MR of the things we're interested in. In this case, we're given magnesium and we're looking for oxygen, so we only need to know those 2. Magnesium is 24.3 and oxygen is 16 times 2 equals 32 because we've got 2 oxygen atoms in that molecule. From this, we've got the mass of magnesium and the MR, so we can work out the moles. Mass over MR equals 192 divided by 24 gives us 7.9 moles of magnesium. Now we use the balanced equation to see that we've got 2 moles of magnesium reacting with every 1 mole of oxygen. That's a 2-to-1 ratio. So we have to divide the moles of magnesium by 2 to get our moles of oxygen. That gives us 3.95 moles of oxygen. And now we've got enough information to calculate the mass of oxygen, which is what the question is asking. So we do moles times MR, 3.95 times 32 equals 126.4 grams. Next, we're asked to calculate the volume of one gas made from another gas. We've got ethane, which in the equation is C2H6, and we've got ethene, which in the equation is C2H4. First, we can use the mass of ethene, 10 grams, to work out the moles. Mass over MR equals 10 divided by 28. That's 0.357 moles of ethene. Please note that I've written 0.357, but I've kept the value in my calculator because it's actually a really long number and I don't want to write all the digits, but it's really important that you keep the full answer in your calculator and never round before the final step. Otherwise you might end up with the wrong answer and get marked down. So we've got a 1-to-1 ratio of ethane to ethene, so we've got the same number of moles of ethane. So we can go back to the equation triangle and do volume equals moles times 24, which is 0.357 times 24, and that's 8.57 dm cubed to 3 significant figures. Finally, this is a kind of question that you might get in a titration example. 13.9 centimeters cubed of vinegar reacts exactly with 25 centimeters cubed of 0.1 mole per decimeter cubed of sodium hydroxide. We want to know what the concentration of the vinegar was. In these types of questions, I always advise doing a little table so you can see what values you have and what you're trying to calculate. So we've got the values for the volume of the acid and of the alkali, as well as the concentration of the alkali. First thing is to convert centimeters cubed to decimeters cubed. So divide both by 1,000. Then we can calculate the moles of sodium hydroxide, the alkali, by doing volume times concentration. That gives us moles of 0.0025. The balanced equation tells us that we've got a 1-to-1 ratio of vinegar to sodium hydroxide. So that means there was 0.0025 moles of vinegar as well. We've now got enough information to calculate the concentration of the vinegar, which is what we're looking for. So concentration equals moles divided by volume, and that gives us 0.1798, which is 0.180 moles per decimeter cubed to 3 significant figures. Make sure you round that correctly. And also note that while at GCSE we did moles per decimeter cubed with this slash, at A level the convention is not to use the slash, but to use the to the power of -3 instead, which means exactly the same thing.
So what's next? Well, at the start of the course, you'll just need to make sure that you're right on top of these GCSE calculations, so the stuff in this video. If you did double science at GCSE, you may have a little catching up to do. If you did triple science, chances are you've learnt most of this stuff before, so just make sure you practice it until you can consistently get the answers right. The main difference between GCSE and A-level is that calculations become more detailed and unstructured. So you'll need to develop the ability to pick out the relevant information from the questions and put them in the equation you already know, and then practice following a calculation from start to finish without the need for a prompt for the next step. As you reach the end of your first year of A-level or IB, you'll start to learn more complex calculations that will assume that the knowledge of these ones have become second nature. So practice, practice, practice. Any questions, comments or queries, just get in touch using the comments below or at Boost Revision on Instagram, Facebook and Twitter, or send me an email at ligaya@boostrevision.com. Thanks very much for watching, and I look forward to seeing you on Lesson 2 on atomic structure. See you there.